Alright, so now let's talk about U-substitution. Now, U-substitution is essentially just a way to integrate the chain rule. Now, if you don't know what the chain rule is, I'll provide a video link to my video on the chain rule, but I'll just summarize it real quick. The chain rule is basically when you're trying to take the derivative of a function within another function. Right, so let's say our function is something like x squared plus 3 cubed, and if we're trying to derive that, we have to derive the outside, so all this stuff cubed, and then also this inside function. So to derive it, it would be 3 times x squared plus 3 minus 1 is 2 times 2x, and this would be our derivative. Now, if I asked you to integrate this, and you had no prior knowledge about what this function was, this would seem kind of tricky, right? Before this, you've been integrating pretty simple stuff like 3x, where you could obviously turn it into x squared times 3 over 2, right? Plus c, something like this, where it's just kind of simple, but here it's got multiple components to it, and you're multiplying, so it makes it just kind of harder. Now, what U-substitution basically does is it takes these functions and their derivatives and it substitutes with a u or a du, and it just makes the entire integration process that much easier, right? So, let me show you what I mean. Suppose we use our example. Let's say 3 times x squared plus 2, was it? I don't remember. It doesn't really matter. And then all this is squared times 2x, and then times dx because you're integrating it. Now, the first step is we try to find our u. Our u is what we're going to be substituting, and it's normally, or it's not normally, it is going to be the antiderivative of this. So the u is almost always the more complex function. So here I see two parts. I see this and I see this. Because this is being squared, you don't want to replace this entire thing. You only want to replace the stuff inside. And you can see that if I put x squared as our u, then when we take the derivative of it, our derivative would be 2x dx. And you have to include this dx because you have to replace this dx with this du, right? It all has to replace itself with in terms of u or du, okay? So, now what we do is we take this and we substitute it. So, 3, and then we see x squared plus 2, so we write u there, squared, and then times, we see this corresponds with this part, so we just write times du. Now, look how much how much more simplified this expression is than this clunky, horrible mess, right? We can simply rewrite it like this, and then just undo the power rule. So this would end up being u cubed plus c, right? And now, since this problem was given to us in terms of x, we simply replace our u with what we used up here. So, x squared plus 2 cubed plus c. This would be our answer. Now, to double check, you can always just take the derivative of this. That's what I always used to do. So, 3 x squared plus 1, 3 minus 1 is 2, and then times the derivative of the inside is 2x. And now you can see that this is the same thing as this, so you have correctly done U-substitution, and you have integrated this horrible mess. Ooh, it's the end screen. Click on one of these links to be directed to that playlist. And don't forget to subscribe!